Hello again. Today you are going to work on the metric system lab. So I am going to, of course, share my screen, but I already have a few things up. I think you probably know how to get into the laboratory folder from the course homepage. So I'm going to skip that step and we're going to go right to the metric system. So here you have everything, the video that you're watching, and of course your directions, which I went ahead and downloaded. So we'll review those very quickly. So for this lab, here's everything that you're going to need. These are common household items. Remember that you should have reviewed your lab material list, purchased anything that you don't already own, and gathered up the household items that hopefully you do own, so that you're ready to do your labs when you make the time. So we're going to be comparing measuring accuracy in this lab. You'll see, here's your activities, here's the links that you'll need. A number of these are just tutorials if you've never used the metric system. For some of us, it's brand new or you haven't seen it since high school. If you need a refresher on how to read a ruler, things like that. And notice activity 5, we don't do in the virtual lab experience. One of the other things you'll use is a different stereoscopic dissecting microscope to measure the field of view in micrometers. And you'll learn what micrometers are in this lab. But this is a different scope than you used in the microscope lab. Okay, so I'm going to go ahead and I'm going to right click this guy. We're going to go open that up. And there's quite a bit of reading to read through here. You don't need to read all of it. It's like the history, okay, of the stereoscopic microscope. We're just going to scroll down and we are going to find the virtual scope. And here it is. Don't scroll past it. It will load. And this is what you're going to be working with for that particular activity. So again, this is pretty straightforward. You are just going to go through all of the different activities. I've put the tutorials ahead of the activity that you would want to review it for. So the metric system tutorial right before you're going to do some conversions, reading the ruler right before you're going to be measuring some lengths. Okay, and then all of those, of course, are consolidated on your directions here and listed at each activity you might want to use it for. If we go over to our lab manual, it's right here. You are, again, just using this for background information, and you also might want to refer to the charts that are in here. So here's the basic units of measure within the metric system. Here are the metric system prefixes, their shortened symbols, and their meanings. So the metric system is really easy to work with because it's a base 10 system. It's meaning it's logarithmic. Every time you move from one whole value to the next, it's by a factor of 10. So understand the difference. This is not a multiple of 10. It is a factor of 10. So it's the exponent of 10. So 10 to the 1 versus 10 to the 2 is what you're working with. So when we go from, say, a centimeter like this, up to a decimeter, you got 10 times bigger. If we go from a centimeter all the way to a meter, you got 100 times bigger. 2 jumps, so 100 times, not 20. It's not 10 plus 10, it's 10 times 10. So you have the exponent value in the meaning, okay? We don't really work with megameters, at least in this class, but you're probably familiar with a kilometer. If you've ever ran a 5K or done any type of race in your life, we all are familiar with the Boilermaker in this area. We have the 15K and we have the 5K. Those are 15 kilometers versus 5 kilometers. And a kilometer is 1,000 meters. And so all of these values here in the exponent, they all refer back to the meter, okay? And you can see that we can convert between the meter, the liter, and the gram at this point too. So all of these prefixes relate to these, technically here would be suffixes. So we have kilometer, kilogram, kiloliter, right? We can have a millimeter, a milligram, and a milliliter. You've maybe worked with some of those before. 10 to the 0, if maybe you remember from your math class, is 1. So these all refer back to the ones place. A deca meaning 10, a decameter has 10 meters. So 10 to the 1 is 10. 10 to the 2 is 10 times 10, that's 100. 10 to the 3 is 10 times 10 times 10, which is 1,000. Now, important to notice, when we get into the upper little echelon here, right, we're getting up into these higher values, we go from an exponent of 3 to an exponent of 6. So that is 3 orders of magnitude greater. And we do it again as we go into the smaller depths here. When we go from millimeter to micrometer, we go from a -3 to a -6. And so that's 1,000 times smaller. Now, this gets very, very, very important in terms of medicine. So, for example, a microgram versus a milligram is 1,000 times bigger than a microgram. This is one of the reasons why, fentanyl is such a crisis in our country. If you give somebody a milligram of fentanyl, you could kill them, because fentanyl is measured in micrograms, and 1 milligram of that is 1,000 times more than 1 microgram. So this becomes really important in nursing and medicine. You have to make sure that you are administering the right medication and paying attention to whether you're measuring out a milligram or whether you're measuring out a microgram, because it literally can mean the difference for somebody's life. So a microgram is 1,000 times smaller. A microliter and a micrometer is 1,000 times smaller than a milli. Now, we are going to be working with the micrometer in this lab. And every micrometer, it's another way to pronounce it, is 1,000. There's 1,000 micrometers in 1 millimeter. So if you think about like the end of my pen tip right here, you can focus on that. That's about a millimeter thick. Within that distance of the tip of my pen, there's 1,000 units of measure. And those units of measure are the micrometer. That is the scale that we use to measure things underneath the microscope, because the microscope magnifies things. And when we're using the microscope, we are peering into the microscopic world, and we need units of measure to measure things under there. So that's what the micrometer is. Now, as you work through this, you're going to review all that information. And I really like this scale because it helps you understand, okay, I'm stepping up versus I'm stepping down. And then we put this little reminder in here. When we go from milli to micro, we're 3 steps. And when we go from kilo to mega, we're also 3 steps. So again, your activities in this lab follow precisely the activities as they are in the lab manual. So it will be all the same answers. So if you want to go ahead and print this out or just complete it, fill in the blanks on your computer, then you'll be ready to just enter that information into the activities on Brightspace. Now, the activities on Brightspace, you have to write them in precisely. So you want to start each number, if it's going to be a smaller number, if it's a decimal, say it's like going to be a 0.5, you want to enter that as 0.5. Because 0 is the place value. We know that there's no other number in that ones place, and we're working solely with a decimal. You do not need to put decimals in whole value numbers. So let's say that the number is going to be 125. You would just write 125 as your answer. You don't need to write 125.00. The zeros are assumed in that case. So just 125 would be fine. Okay. If you have any problem with entering the numbers and you're pretty sure that you got the question right, but it's not reading it correctly, please let me know. I don't anticipate any problems here, but you never know with how, things go. So you're going to answer all these questions. This is the same thing. Here's using the micrometer. This is just a little bug. It's just a graphic, and this bar right here is a scale bar. So what this is telling you is, as you're looking underneath your microscope, for example, all right, we're using our imagination here. You see a bug that looks something like this, and then sometimes there's tools that we use in microscopy that have printed scales on them, and you're going to use one in this lab called the stage micrometer. Well, sometimes you can insert a slide that has a scale bar on it to help measure things that you have underneath that slide. And in this case, this little bar represents 20 mu, and mu is the symbol for the micrometer. So you're going to use this, and you're going to use that to estimate the width and the length of this bug. What I like to do is just take a little piece of paper and, you know, line it up to the scale bar, mark it off, and then kind of use that piece of paper to measure across and measure the width. And then you're going to estimate, okay? And then you enter that, of course, into the Brightspace activity. This is just showing you what the micrometer looks like blown up underneath the microscope. You're going to answer some questions according to that. And the rest is pretty self-explanatory. Now here, just create your own description. You do not need to do research. I do not need references. And if you tell me that this is the kneecap, you're going to get it wrong. Okay. The meniscus in water is very different than the meniscus that's in your knee. So there's that. Hopefully you watch this video, you don't answer that incorrectly. And so you're going to be measuring. So here's where we diverge from the activities in the in-person, you know, so here we're reading the lab. Activity 8 does not correspond precisely to the activity that you're going to do at home. The activity that you are going to do at home involves measuring with teaspoons, like a baking teaspoon and a teaspoon that you use in your coffee, for example, and a measuring cup versus, you know, a coffee cup. Now listen, there's many types of coffee cups, okay? Try to use like an average sized coffee cup, not your gargantuan, huge, I need to be heavily caffeinated mugs, but like a normal mug. Otherwise, you're going to be, because you're going to spoon tablespoon by tablespoon into your cup. It's going to take you all day if you're going to use one of those big ones. Okay, so use like a normal size. We're trying to compare the difference between a coffee cup versus a measured cup, and to see if your coffee cup is as accurate as your measuring cup, which, you know, it shouldn't be, but once in a while a teacup actually winds up being precisely the same as a measuring cup. So, you know, choose your cup wisely is what that means. Okay, so then you're just going to finish these activities. And I believe that is the last thing that we needed to talk about. So I will stop sharing my screen, and I will see you all in the next video.